So we can solve this using factoring, both using a calculator and doing it by hand. By hand, two things. I want to identify what the solutions are and also come up with the equation. Notice my leading coefficient is 8. So to figure out this by factoring, I know 8 times -3 is -24. Two numbers that multiplied equal -24 and combined to give you -2 would be x minus 6 and x plus 4. Now when we're solving, I'm going to set this equal to 0. Because when we solve, we're really trying to find the x-intercepts. And in that case, y will always be 0. I take the leading coefficient, which is different than 1, I put it underneath. I end up with reduced 3/4, reduced 1/2. That tells me that my solutions are going to be positive 3/4 and negative 1/2. Okay, those are my two x-intercepts. There's no I involved. How do I write this in factored form? Y equals, now I get to push up 4x minus 3 and 2x plus 1. I want the leading coefficient when I do foiling, front, outside, inside, last, or first, outside, inside, last. I want it to be a positive 8. Do these two multiply to give you a positive 8x squared? Then there's your answer in factored form. How can you quickly do this with the calculator? Okay, with the calculator, I'm going to plug it in, as you can see, and I'm going to graph it. I'm going to identify both x-intercepts by going second trace 0. Left bound on the left is above, right bound is below, and back to it. So I can see one of them as a fraction is negative 1/2. The second is positive 3/4. We can see whether we use a calculator or we do it by hand by factoring and get the exact same answer. Now how do I write this in factored form if I don't go through these steps and instead of I use technology? Y equals, this has to be opposite, x plus 1/2, opposite x minus 3/4. I push up and I push up. Y equals 2x plus 1 and 4x minus 3. Do these two multiply to give you a positive 8x squared? Factored form and our two solutions. For this problem, we'll do one more time where I can show you factored form or we can use technology. So when I want to find the solutions, I'm going to set this equation where y, instead of having y, I'm going to set it equal to 0. Negative 9 times 4 is negative 36. Looking for two numbers that multiply to give you negative 36, combined to give you negative 9. X minus 12 and x plus 3. Bring the negative 9 down underneath both. Two negatives make a positive. Positive divided by a negative is a negative. And now I'm going to reduce those fractions. So this reduces to 4/3. This reduces to 1/3. And now I'm able to easily identify the solutions. Remember, it's opposite. So x equals negative 4/3 and x equals opposite positive 1/3. That's the first task. The second task is how do I write it in factored form. So I'm going to take this equation, I'm going to write y equals, pushing it up, 3x plus 4 and 3x minus 1. Now before I go any further, let's multiply the fronts. What is 3x times 3x? 9x squared, but what do I want? Negative. So what's the only thing I have to multiply by? Done. I would like you just to watch, but not to do this. I want to show you how the two are the same. So I'm going to plug this in right now. Negative 9x squared, you're just watching, subtract 9x plus 4. And then I'm going to plug in what I believe is equivalent in a different form. 3x plus 4 and 3x minus 1. And I'm going to graph them. One will be blue, the second will be red. Do they appear to be the same? Here's how you can show they are. Second table. Do they have the exact same numbers? These are equivalent, but in just different forms. Now this is, I solved this using factoring. Now we're going to use technology. I'm going to flip it around. You're going to do this one with me. So please plug this into your graphing calculator right now. As you're plugging it in, please listen. in previous hours, the mistakes I saw students make as they plugged it in is they often put, this should be a negative sign in front, and the second one should be a subtraction sign. You may be wondering why she's showing us two ways, because if you don't have a graphing calculator at home, then you need to see, can I do this by factoring? Not every quadratic equation will be factorable, but since that's the lesson today, everything is factorable. All right, here we go. Second trace zero. We're going to identify the zeros this time using technology. So I'm going to use the arrows, come over here to the first x-intercept on the left. I'm going to go below it, left bound, above it, right bound, and back to it, and press enter. Okay, so you may be wondering, what the heck are these answers? In scientific notation, this is really equivalent to 0. It's like negative 0.00000011 times and a 1. So this is negative 1.3 repeating. We're going to come back to that in just a second. Please write it down. That is one x-intercept. The second can be found by doing second trace 0. Left bound is above, right bound is below, and I come back to it. And I'm going to write down x equals 0.3 repeating. Not everyone is great at, in their mind, transitioning from a decimal into an equivalent fraction. If that happens to be you, please press clear. And I'm going to type this in, negative 1 point, and I'm going to put a lot of 3's behind it. And then I'm going to come up and hit math, fraction, enter, enter. So one solution is negative 4/3, and I can see that we already did that using a previous method. And then the next one, again, if you didn't know this, you'd type in 0.3 and put a lot of 3's behind it. Do math, fraction, enter, enter. Another one is 1/3. So if I use the technology method, I'm going to write down y equals x. Remember, I do the opposite sign, x plus 4/3 and x minus 1/3. And then I'm going to push up here, so I have 3x plus 4 and 3x minus 1. But now ask yourself, 3x times 3x, is it a positive 9x squared? No. What do we still need to multiply to get that? Negative 1. 3x plus 4 and 3x minus 1. Let's start with factoring. So again, two tasks. What are the solutions? And what does this look like in an equivalent but different form, factor form? Bless you. So I'm going to first take this, and I'm going to set this equal to 0 instead of equal to y. And again, if you need a little refresher, why are we doing that? Because we're really finding the x-intercepts. Y is always 0 in that case. Then I'm going to take out a 2, and I have x squared plus 9x plus 20. Do I know two numbers that multiply to give you 20 and combine to give you 9? Brandon, head up, work. Do you know two numbers that multiply to give you 20, combine to give you 9? The two numbers would be x plus 4 and x plus 5. Now I can easily identify the x-intercepts as x equals negative 4 and x equals negative 5. Okay, good so far? Keep in mind what we need to do over here. Let's see if we get the same. So I have x plus 4 and x plus 5. The leading coefficient is a 1, so I don't need to do bottoms up. And I have y equals, I'm writing this in factored form. X times x is x squared. I don't want just an x squared, I want a. So what do I need to multiply by? I need to multiply by 2. Now let's just confirm that this works. So I'm going to come up here and I'm going to type in the original. You're welcome to watch. 2x squared plus 18x plus 40. This should be in blue. I can see it in blue. Okay, then I plug in my second different option, which is going to be 2 times x plus 4 and x plus 5. Let's see if it looks the same. Not only does it look the same, let's confirm. Second graph. Are they the exact same numbers? They are. How can we do this using technology? Because that is an option for you now. Please do me a favor. Please go and plug this equation into your graphing calculator. All right, and I'm going to graph it, and now I'm going to identify the x-intercepts. I can see there's 2. Second trace 0. I'm going to go to the left here. I'm just going to hold it down. I'm going to watch it. Okay, to the left of the first x-intercept. Somewhere to the left, enter. Somewhere to the right, I'm creating those boundaries as you can see. And now back to it. One answer is -5, so x equals -5. That's one solution. Second, trace 0, below, above, and back to it. Another solution is -4. So I've identified using technology the 2 solutions. How do I turn it into factored form? Y equals opposite signs, x plus 5 and x plus 4. And now let's check if it's necessary. If I multiply the fronts, or the first, like foiling, x times x is x squared. I don't want just x squared, I want 2x squared. So I'm going to place the 2 in front, and we've already shown that this is the exact same. So in this 4th example, let's make the decision right now to say, okay, I'm going to solve this by factoring right in factored form, and I'm going to use technology. Personally, when I see fractions, often I automatically go, let's use technology, okay? So let's go up here, and let's plug this in. Now, plugging this in is just a little more complicated. It starts with an x squared, subtract, not negative, in parentheses 5/3 with an x outside of the parentheses, plus parentheses 25 over 36. Graph it. What's unique about this problem compared to the first 3 we did is it only touches the x-axis one time. Let's identify that solution. Second, trace 0. To the left of the 0, to the right of the 0, and then guessing. Now, not everybody is great at memorizing what this is as equivalent fraction. If that happens to be you, you are going to clear out of this, and you're going to go 0.8, and you're going to write down a lot of 3s. And then hit math fraction, enter, enter, and we can see the answer is x equals 5, 6. That is the solution. Remember, this is squared. This is degree 2. So what does this look like? Y equals, there's 2 of them at this exact same spot. It bounced off. So y equals possibly some number, x minus 5/6 and x minus 5/6. We're going to confirm our answer is right in just a second, but if I multiply the fronts, you'd get x squared. Front times front, x times x is x squared. I don't need to multiply any number here, it's just a 1. Let's make sure that we did do this right. So I'm going to go to the second equation, and slowly I'm going to type this in. X subtract, in parentheses, 5/6. And I could write this quantity squared because they're the same exact parentheses written twice. Are they the exact same thing? They appear to be. How can we confirm? Second graph, are they the exact same? Yeah. This works. You are going to practice a problem right now, and let's see if you can get this right. Is everybody ready? Y equals 15x squared minus 8x plus 1. You have a choice right now. Actually, with the time remaining, I'm going to put it on pause. I'd like you to do it both ways. When I did this the first time, I didn't zoom in, and I thought it appeared like there was only one root. But when I zoom in, can everybody see how there's actually 2 roots? No. There's actually 2 roots here. So I'm going to zoom in even a little bit more. I'm going to go from 0 to 3, and now I'm going to identify those 2 roots. Second, trace 0. Okay, so the first root is 0.2. Sorry, I'm going to write down x equals 0.2. Anybody remember what that is as a fraction? 1/5. Nice job. Now I'm going to do the next one. Second, trace. You would not have missed the second one if you did by factoring by hand, by the way. And now I'm going to do graphing. Left bound, right bound, and back to center. And this time it is 1/3. X equals 1/3. Okay, so keep those in mind. Now in factored form I have x minus 1/5 and x minus 1/3. Then I push them up because they're already reduced. And I ask myself, is 5x times 3x 15x squared? Okay, that is what I believe the answer to be, so I'm going to plug it in and see. 5x minus 1, bless you, 3x subtract 1. I'm going to graph them. They appear to be right on top of one another. Second graph, and I can see they are the exact. This next part, what we are going to do is we are going to solve not using factoring. We're going to solve by completing the square. We're going to start off with what is really like a mainstream Algebra 1-2 problem. And we're going to go through this really quickly. If you want to just watch the first one and take notes, feel free to do that. So this right now is just an equation set equal to 0. We are solving this equation for x. We want to know what can I substitute in for x. So when I square that number, I take it times 4 and subtract 12, I will always get 0. It appears like there should be two answers. It may be the same answer twice, but it appears like there should be two answers. That's what this tells us. First step is to make sure this number is a 1. I'll show you in the next example what to do when it's not a 1. Then take the c and move it to the opposite side. I know that when I move it to the opposite side, it changes sign. So 0 plus 12 is 12. Replace that position with a plus and a blank spot. This will always, always, always be a positive sign. The next step is to identify what the b is. Not only is it a 4, it's a plus 4. And we're always going to take it, that plus 4 in this case, and you're always going to divide it by 2. Then we're going to do the math. 4 divided by 2 is a positive 2. And I'm going to put a little star next to that because it's going to allow me to do a shortcut in just a little bit. The third step here is we're going to take that positive 2 and we're going to square it. Whatever that is goes into this position, and to keep the equations balanced, it also goes to the right. 2 squared is 4. I added 4 to the left, I must add 4 to the right. Now here's where we get to do a shortcut. I would ask you to factor this, but we get to do the shortcut. I get to write x plus 2 quantity squared inside. Whatever this is goes right behind the x. Why is it a positive? Because positive 4 divided by 2 is a positive 2. And 12 plus 4 is 16. Okay, to solve for x, I'm going to square both sides. And when I simplify, the square root and the squares cancel. This does tell me I'm going to have two answers. I know the square root of 16 is 4. And now I'm going to subtract 2 from both sides. And I'm going to put that negative 2 in front of the plus or minus. How do I get two answers? One time I add, and the other time I subtract. So what this tells me is that if I take 2 or negative 6, I square them, and then I take 4 times that same number, subtract 12, I will always get 0. There are only two answers that ever you're able to plug in for x in this particular equation, and it will equal 0. Okay, just like the previous problem, the first question is the leading coefficient 1? If it is not, you take whatever this value is and you divide every term in the equation by that value. Divide by 2, divide by 2, divide by 2. Please make sure you're writing these down. Now 2 by 2 is 1. I'll be able to do this problem. 9 halves doesn't reduce, 7 halves doesn't reduce, and 0 divided by 2 is 0. In the last problem, the very first step, because we didn't have to make this a 1, the very first step was to move the c to the opposite side. How do I move a positive 7 halves to the opposite side? Every step will be the exact same as the previous problem, and we're going to use a calculator when we have to work with fractions. 0 subtract 7 halves is a negative 7 halves. Okay, now I'm going to identify what the b is, and I'm going to write the b down. And you're always going to divide it by 2. So I have a positive 9 halves, and I will always divide it by 2. Some people are going to do that in their head quickly. Others will rely on a calculator. That's okay either way. So if you want to use a calculator, you're taking 9 halves, put it in parentheses, and dividing it by 2. Turn it back into a fraction by hitting math, fraction, enter, enter. So 9 fourths, 9 fourths. It is a positive 9 fourths, and I'm going to put a star underneath that. It will allow me to do a shortcut and do less work in the next few steps. Okay, now I'm going to square this. So 9/4 squared. Well, this is actually quicker to do in our head. 9 times 9 is 81. 4 times 4 is 16. This will always be positive. So if I add 81 over 16 to the left, I must also add it to the right to keep it balanced. On the left-hand side, I don't have to think. I could tell you, please factor this, but guess what? It's even easier. Whatever this is, I just bring it straight down, 9/4, quantity squared. Now, I could also tell you find a common denominator and combine like terms here afterwards. But what we're going to do is we're going to use a calculator. Let's plug in -7/2 plus 81 divided by 16. Once we get an answer, we'll turn it back into a fraction. 25 over 16. Ultimate goal here is to solve for x. So to do that, I'm going to take the square root of both sides. Remember, this means 2 answers. And when we simplify, the square root and the square cancel. I know the square root of 25 is 5. The square root of 16 is 4. Now to isolate the x, I'm going to subtract 9/4 from both sides, keeping it in front of the plus or minus sign. Because we have a common denominator, you can do this in your head, or feel free to use that calculator if that's what you prefer. -4 over 4 is -1. Bless you. -14 over 4, -14 over 4 reduces to -7/2. In this problem, we first need to make sure the leading coefficient is a 1. I see a 1, but there's a 0.0 in front of it. So I'm going to move this decimal to the right 2 places, and then I must do the same to every other term in this equation. 1, 2, 1, 2, 1, 2. So this is 1x squared, subtract 22x, plus, and this empty space becomes a 290. And when I plug in zeros, 0, 0, 0 is still just the same as 0. The very first step is to move c to the opposite side. In this case, we are going to subtract it. Zero minus 290 is a -290. Remember, this is always going to be a plus with the blank spot. The second step is to identify what our b is. Notice that this time it's negative. So I take whatever b is and I divide it by 2. b divided by 2 in this case is a -11, and I put a star underneath it. It'll speed up the process in a few steps. The third step underneath here is to square that number. -11 times -11 is a positive 121. If I add it to the left, I must always add it to the right. Okay? Now, I would normally tell you, go ahead, factor this, but this is why we get to use a shortcut. It's x, in this case, minus 11, whatever had the star, quantity squared. If I asked you to grab your calculator and take -290 plus 121, you'd get a -196. 169. Sorry, -169. Okay, to isolate the x, I'm next going to take the square root of both sides. Remember, this gives me 2 answers. But you can't take the square root of a negative number, so that comes out front, and the square root of 169 is actually 13. Now I'm going to add 11 to the opposite side, and I get x equals 11 plus or minus 13i. That is 2 answers. One time you're adding, the second time you're subtracting. Anytime you have an I in your solution, what it means is that this quadratic equation, this U-shaped parabola, will not have an X-intercept. It will be something like this. It's either going to open up above or it'll open up below, but it will not cross.